Hello, year fives. I hope this week's gone okay. We're on day 3 now, hopefully. You've done day 1 and 2, done some mental maths, did some balancing of equations yesterday. I hope that went okay. We're doing something different this next couple of days. We're looking at area. And today's lesson, I think, should be a breeze. It should be good practice. This is what we're doing today. We're just reminding ourselves of how we do things, all right? Because we're looking at area, and today we're just looking at squares and rectangles. Bish, bash, bosh. Bang, 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 should be complete, okay? And we'll look at this this rectangle, sorry, here, and we can work out its area. We want to know what its area is, remembering that area is the space it covers, all right? Perimeter, distance around the edge, we just measure that with a ruler, or we can count things if you want. Area is the space it covers. And we can see our paper handily has been broken up into centimeters squared. So we could just count each centimeter squared, couldn't we? Because that's how we measure area. Do you remember? We measure area in centimeters squared or meters squared or kilometers, anything like that, but with smaller things in centimeters squared. And this one, we could just count each centimeter squared. We've got 1 centimeter squared. We've got 2 centimeters squared. And oh, no. But there are better ways, all right? That's probably year 3, maybe year 4's a little. We're in year 5 now, so we're going to remind ourselves of the quick way to work out the area of a rectangle. Here's another rectangle, not quite so helpful because it's not on a piece of squared paper. So we're going to have a look at this one now. We'll come back to our other rectangle in a moment. Because the question, I suppose we could ask how many square centimeters would be inside this rectangle. Well, we would have 1 here, 1 here, 1 here. That would be 1, 2, 3. Then another, and then another. But we don't need to do that. We can just calculate it without counting any squares. Do you remember how? Hopefully you do. We can multiply the length, however many centimeters are along here, by the height or the width, whatever you want to call it, which is 3. So we've got 7 centimeters this way and 3 centimeters this way. So we're going to have 7 centimeters squares, and then 7 more centimeters squares, and then 7 more centimeters squares. That is 7 times 3, girls and boys. And the answer, hopefully, you should know, is 21 centimeters squared. And if we do that with the top one, 8 times 5 is 40, all right? So we can do that with any rectangle we like, okay? And it's really important that we're really comfortable remembering that all we have to do to find the area, the space that it covers, is multiply the length by the height. And our answer is in units squared, this little 2 here, okay? Because it is square centimeters that it is covering, okay? Interesting. Is it always centimeters squared? No. If a school hall was having a new floor and the price was based on its area, how would we calculate the area? Would we measure it in centimeters squared? Our school hall? Can you imagine how many centimeters that would be? It would be a lot of centimeters, wouldn't it? What would you measure it in? How would you measure it, do you think? What would you use? Would you use a tape measure? Would you use a little 30 centimeter, 50 centimeter? Maybe you'd use one of those clicky things. What do they measure in? Hopefully you'd measure it in meters squared, because we would measure the length and the width of the hall in meters, wouldn't we? It wouldn't be centimeters, so we'd measure it in meters squared. How about some other things then? Here are some measurements. 12 meters squared, 120 meters squared, 12 centimeters squared, 28 centimeters squared, 100 millimeters squared, and 28 millimeters squared. Which of these could be the area of a bedroom floor, do you think? Which of them could be the surface of a little fingernail? Which of them could be the face of a credit card? I'll show you my credit card, but I'm sure you'll write down the number and then go and spend it. What do you think? Any ideas? Hopefully, you had these ideas. Maybe that the fingernail would be 100 millimeters squared. That's quite a lot to me. Oh, about 28 millimeters squared. Maybe mine's quite. Oh no, 10 mil by 10, maybe 10 by 10, maybe. And interestingly, weirdly, 100 millimeters squared is 1 centimeter squared. Okay, maybe 28 millimeters squared is a bit small. Credit card, roughly 28 centimeters squared. A bedroom floor, probably 12 meters squared. We measure a meter squared, but it's not massive, is it? It's not like 10 meters by 10 meters. It is probably I don't know, 6 by 2 or 3 by 4, something like that, that we would measure. So that's what you're going to be doing today. You're going to be thinking about using your understanding of measurement and to work out some areas of rectangles. And tomorrow, you're going to be thinking about a bit more non-standard shapes, maybe like a fingernail, all right? And you're going to be thinking about, well, I can't quite do that so easily. I might have to count some squares. I might have to find some rectangles within it and then add those areas up, all right? So have a look carefully at tomorrow's learning reminders when you get there tomorrow and see if you can work out some interesting areas of some interesting shapes. I think it's mostly leaves, but you might be able to go away and find some other interesting shapes. You could do the area of your hand, you could draw around it on your centimetre squared paper. Think about what it would be. Have a go, do some good maths, and I'll see you soon. Bye, Year Vibes.